A class contains 18 juniors and 10 seniors. 12 of the juniors are females and 6 of the seniors are females. A student is to be selected at random. Find the following probabilities that either a junior or a female is selected, either a senior or a female is selected, or that a junior or a senior is selected. We could make a table that would summarize all of this information. We have juniors, we have seniors, we have females, and we have males. So we'll construct a table then that'll have all this information in it, and we'll have some totals then for the columns and the rows here. Now we have a total of 18 juniors and we have a total of 10 seniors. 12 of the juniors are females, which would leave 6 to be males. 6 of the seniors are females, which would leave 4 to be males. And then we can see these other totals over here. We'd have 18 total females and 10 total males. And either way, we have 28 total people. Now, using the addition formula, we have the probability that we'd have a junior or a female would be the probability that we'd have a junior plus the probability that we'd have a female minus the probability that we have someone who has both attributes, female and junior. So the probability that we would have a junior is 18 out of 28. The probability that we would have a female is also 18 out of 28. And we find those things here, 18 out of 28 for juniors and 18 out of 28 for females. Minus the probability that we would have a junior and a female. So there are 12 that have both of those attributes. So 12 out of 28. And we have to do that because they're counted in there twice, once with the juniors and then again with the females. So we have 36 minus 12 is 24 out of 28. The probability that we'd have a senior or a female would be the probability that we would select a senior plus the probability that we would select a female minus the probability that we would select someone with both attributes, a senior and a female. So we have 10 seniors out of 28 people plus 18 females out of 28 people. But now, those that have both attributes, again, have been counted twice. Well, we have 6 who are seniors and females. So we'll subtract that out, which is going to give us 22 out of 28. The probability that we would have a junior or a senior. Now, these are mutually exclusive events, so we don't have to do the subtraction. These two things cannot occur at the same time. No one can be a junior and a senior at the same time. So all we have to do here is find the probability that we have a junior plus the probability that we have a senior. Well, we have 18 out of 28 who are juniors and 10 out of 28 who are seniors for 28 out of 28, which is a probability of 1, which we expect. This is a certain event. If I have a classroom that has no one in it but juniors and seniors, then there would be certain, if I select a student at random, that I would get either a junior or a senior. An insurance company classifies its insurees as either low risk, medium risk, or high risk. 60% of those that they insure are classified as low risk, 30% are classified as medium risk, and 10% are classified as high risk. 1% of the low risk insurees had an accident in a given year. 5% of the medium risk insurees had an accident, and 9% of the high risk insurees had an accident. We're to find the probability that if an insuree is selected at random, that person had an accident. Now, in this particular case, we're not given a bunch of raw numbers. We're given percentages, and so the best way to treat this is to go ahead and create a table, but what we'll do is we'll assume a total, and a total that is a power of 10, like 100 or 1,000, is always going to be the easiest to use, because when we're working with percentages, all you got to do is just take away zeros and such. So we'll start to make this table, and we'll note that we have low risk insurees, medium risk insurees, and high risk insurees. Then we have people who have had accidents, and we have people who have not had accidents. And then we'll extend these down so that we can make totals for each of these things. And what we'll do is we'll just assume a total of 1,000. Now we can start filling in the totals for the low, medium, and high risk columns. 60% of 1,000 is 600, 30% of 1,000 is 300, and 10% of 1,000 is 100. We're told that 1% of the low risk insurees had an accident. So we'd have 6 in this entry here, 1% of 600. And then we're told that 5% of the medium risk insurees had an accident, which would give us 15 in this cell here, which is 5% of 300. And then we're told that 9% of the high risk insurees had an accident, which puts a 9 here, 9% of 100. Then that leaves 594 for this cell, because the low risk insurees either had an accident or didn't have an accident that was reported. It would leave 285 here. 15 plus 285 is 300. And then we'd have 91 here. 9 plus 91 is 100. And then we have the total number of people who had an accident, and that would be 30. 6 plus 15 is 21, plus 9 is 30, which would leave 970 for this cell. We can get that either by taking 1,000 minus 30 to give us 970, or just adding the entries in the cells of those who didn't have accidents. So now, using this table, we can find these probabilities. The probability that someone had an accident, now we have 30 total people who had an accident out of 1,000. Or 3 out of 100, or 3%, or 0.03. However, we need to report that. The B part asks for the probability that someone had an accident given they were a low risk classification. Okay, well, That means that we are only working with this column. We're told that they are low risk. So there's 600 people who are low risk out of this 1,000. And of those 600, 6 had an accident. So this probability is going to be 6 out of 600, or 1 out of 100, or 1%. But we already knew that. We were told that at the beginning of the problem. But what if we were to reverse that? What if we were to find the probability that we had a low-risk person given they'd had an accident? Well, that changes things around a little bit. Now we're working with this row. We're given that the person had an accident. Well, there are 30 total people who had had an accident, and 6 of those were low risk. So that's 6 out of 30, or 1 out of 5, which we could call 2%, 20% rather, or 0.2. A drawer in your kitchen has 8 AA batteries in it. 3 are defective. If 2 are selected at random without replacement, what is the probability that both are defective? So we have a drawer here. It has 8 AA batteries in it, and 3 are defective. That leaves 5 that are not defective. Now we're going to select 2 at random, and we're supposed to find the probability that both are defective. So that's 2 defective, which is the same as saying that we would have a defective and a defective. And the word "and" tells us that we are going to multiply. The multiplication rule tells us that we would have the probability of D and D would be the probability that we would get a defective times the probability that we would get a defective given we got a defective on the first draw. We can make a tree diagram that would illustrate this. On the first selection, we're either going to get a defective or not defective battery. There are 3 that are defective, and there are 8 total. So the probability that we would get a defective battery would be 3/8. The probability that we would not get a defective battery would be 5/8. Now we are not going to replace the battery. We're going to make a second selection, and we could either get a defective or a not defective battery, whether we got a defective or not defective on the first draw. If we got a defective on the first draw, the probability that we would get a defective on the second draw would be 2 out of 7. If we got a defective on the first draw, the probability that we would get one that is not defective on the second draw would be 5 out of 7. The probability that we would get a defective, given we hadn't gotten a defective on the first draw, would be 3 out of 7. And the probability that we would get one that is not defective, given that we got one that was not defective on the first draw, would be 4 out of 7. Now what we're looking for are these two here. The probability that we would have a defective and the probability that we would get a defective battery given we got a defective one on the first draw. So this will be 3/8 times 2/7, which we could reduce. The 2 and the 8 would make a 4 and a 1, so we'd have 3 out of 28.